Hey guys, let's finally start doing the 2024 section B for math methods, so extended response. So let's see how we go. Okay, so consider the function f of x equals to this, where a is r. State in terms of a where required the values of x for which f of x is 0. Okay, very well. So for f of x to be 0, that's simply asking us to list the x-intercept. So let's do that. So x is equals to -1, x is equals to -a, x is equals to 2, and x is equals to 2a. Okay? Find the values of a for which the graph of y equals to f of x has exactly 3 intercepts. Okay, so for this, now notice how this and this are always going to be a solution. So we already have 2 fixed solutions, right? So how can we only get 3 if we have 2 solutions already done? Well, so we have to look at a couple of different scenarios. First of them is that when this and this are equal. Okay? So let's do that real quick. So negative a is equals to 2a. So we get a is equals to 0. Okay? That's first scenario done. Now, we have to see what happens when 2a is equals to 2. Right? So that's also one of the scenarios. So 2a equals to 2. So a is equals to 1. Okay? Now, we have done that. Now let's see. We already done this as well. When 2a is equals to a, we already done that. Now there's one more we have to do, which is when 2a is equals to -1. So 2a is equals to -1. So a is equals to -1 on 2. Okay? Now we do the same for the other one, which is going to be this one, right? So we first see what happens when a is equals to 1. So that's 1 done. So a is equals to 1. Now let's see what happens when a is equals to 2. So negative a is equals to 2. So a is equals to -2. The third one, we already done it, which is right here. Okay, so we have covered all the cases possible to obtain 3 solutions. Now let's see if all of them are actually giving us 3 solutions or not, because a equals to 1 is common between both. So there might be some discrepancy. So what happens if I substitute a equals to 1 in the following equation? So our equation becomes x plus 1 times x plus 1 times x minus 2 and x minus 2 equals to 0. So the only possible solutions for this one are x equals to -1 and x equals to 2. So this only gave us 2 solutions. So that does not satisfy the question. So the question is asking for 3 x-intercepts, while a equals to 1 only gives us 2. So we can't have a equals to 1 as a valid solution, so let's remove that. Let's try the other 3 values though. So a is equals to 0. Let's try a equals to 0. So we get x plus 1 times x minus 2 and times x again. So we have x equals to 0, x equals to -1 and 2. 3 intercepts, that's good. Now let's try a equals to -half. So x plus 1 times x minus half times x minus 2 times x plus 1. So this will give us x equals to -1, x equals to a half, and x equals to 2. So 3 solutions, we are good. Alright, now let's try the last value, which is a equals to -2. So x plus 1, x minus 2, x minus 2, and x plus 4 equals to 0. So again, we have 3 solutions. So x equals to -1, x equals to 2, and x equals to -4. So there you go. So that means our 3 a values are correct. So these ones will be the answer. Okay? Okay, exactly 4 intercepts. So if we found the a values for exactly 3 intercepts, all we have to do is to reject the 3 values for finding the 4th intercept, right? So if we want exactly 4 intercepts, then we have to reject the values of a, which gives us 3 intercepts or less. So what happens is, all we have to do is that a is all real numbers except -2, -half, and 0. Are we missing something? Yes, we are also missing the fact that when a is equals to 1, we only get two x-intercepts, right? So x plus 1 times x plus 1 times x minus 2 and times x minus 2. So as you can see, that only gives us two intercepts. So we also have to reject that value. So let's do that real quick. And after rejecting that value, that pretty much should give us 4 intercepts at any other value of a. Hopefully this makes sense. So let's move on to the next page. So let g be the function where a equals to 1. Okay, find the derivative of g. Okay, so for this, let's do this on CAS. So define g of x is equals to x plus 1 squared, and times by x minus 2 squared. Okay, enter. So let's find the derivative. So define g of x is equals to menu for 1 x g of x, and now let's list the g of x. Okay, cool. So our derivative is going to be 2 times x minus 2, x plus 1, and 2x minus 1. Find the coordinates of the local maximum of g. Okay, so solve dg of x equals to 0, x. So there you go. These are our x coordinate for the turning points. Now, how do I find, which one is the local max, which one is the local mean? Yes, we can substitute the values of x into our g of x, but that means we have to substitute 3 values. So what I'm going to do, I'm going to just plot the graph instead. So if I were to do add graphs, there you go. So as you can see, this is -1, half, and 2. So we can clearly see that our maximum is going to occur when x is equals to a half. So this saves some time while also giving us an advantage of having a visual, ready for future questions. So our local coordinates, local maximum coordinates will be half and 81 on 16. Okay, find the values of x for which derivative of g is greater than 0. Okay, so again we just do this on CAS. So greater than 0, press enter, and these are the values. Okay, so x is between -1 to a half exclusive, including 2 to infinity. Okay? Alright. Consider the two tangent lines to the graph y equals to g of x at points where x is this and x is that. Determine the coordinates of the point of intersection of these two tangent lines. Okay, so let's find the tangent line first using the tangent line function. So menu for 9, g of x, and let's type the x coordinate, which is negative square root of 3 plus 1 over 2. Okay, so that's our tangent line 1. Now the second tangent line, we remove this. There you go, that's our second tangent line. So let's quickly write them down. So y of 1x, so this is our first tangent line, that is going to be 3 root 3x. Take away 3 times 2 root 3 minus 9 divided by 4. And our y2 of x, which is going to be minus 3 root 3x plus 3 times 2 root 3 plus 9 divided by 4. Okay, so to find the point of intersection of these two tangents, we just have to equate them to each other. So y1 of x equals to y2 of x. So solve that is equals to that, comma x. There you go. So our x is equals to a half. And now we just have to substitute that back in to either of the tangent line equations that we found to get the y coordinate. So this is our y coordinate. So let's write the stuff down. So y1 of half is equals to 27 on 4. So therefore, our point of intersection is equals to half on 27 on 4. Okay? Alright, next question. Let g remain as the function this, okay? Let h be the function this, which is the function f, where a is equals to -1. Okay, so let's define h of x now. I should have defined f of x earlier on so that, I could just simply substitute in values of a and it'll be easier for me to define. So this is where the actual reading time comes into play. It helps you strategize all of your questions, so make sure you guys use it effectively. X plus 2 times x minus 2. Okay, alright, so let's define that now. Using translations only, describe a sequence of transformations of H for which its image would have a local maximum at the same coordinates as that of G. Okay, so first we have to find the coordinates where H will have the local maximum. So let's differentiate H. So define dH of x is equals to menu for 1 x h of x. Okay, so solve dH of x is equals to 0. So these are our coordinates for the turning point or the stationary point. Now again, we can just simply graph this to save our time of substituting, just once rather than having to do it 3 times. So as you can see, our maximum is going to occur at x equals to 0. So h of 0 is 4. Okay, so basically our local maximum for G, I believe, was half and 81 on 16. Yep. So half and 81 on 16. And for H, we found it to be 0 and 4. Okay? Using translations only, describe a sequence of transformations for H for which its image would have a local maximum at the same coordinates as that of G. So we want to list a transformation such that 0 and 4, which is the local maximum of H, will become half and 81 on 16. That's pretty easy, right? So all we have to do is to translate half units in positive direction of h-axis and then we have to translate 81 over 16 minus 4 units up. So 81 on 16 take away 4, so 17 on 16. So translate, actually I'm better off writing y-axis rather than that. So translate 17 on 16 units in positive direction of y-axis. Oh wait, this one has to be x. What am I doing? Yeah, x-axis, y-axis. Okay, and this should be your answer for this question. Hopefully nothing too fancy or hard. Okay. Alright. So using a dilation and translations, describe a different sequence of transformations of H for which its image would have both local minimums at the same coordinates as that of G. Okay, so now we have to find the local minimum. So let's find G of, what was the local minimum for G and H? Okay, so G of minus 1. So G of minus 1, we have 0. Okay, so the local, okay, so for this, we have to make sure that our local minimum for G, which is minus 1 and 0, and 2 and 0, and our H, we have the local minimums at the other 2 points. So H of x, given that x is equals to this. Okay, so H would be negative root 10 on 2, comma minus 9 on 4, and then the other one would be at root 10 on 2 and minus 9 on 4 due to the symmetry. If you look at it here, yeah, the graph is symmetrical, so it will have the same y coordinate as well. Okay, so now what we have to do is to list the dilation and translations that would make the H coordinates become that would make the local minimums of H become local minimums of G, essentially. So basically we have to go from here to here, and we have to go from here to here. Now translation in the y-axis is pretty simple. All we have to do is to move 9 on 4 units up. But for x, what will happen? We can't really see how we can make, negative root 10 on 2 to negative 1. Pretty hard to just see that or to list the transformations. So what I'm going to do is I'm going to make equations for this. So our equation would be negative root 10 on 2 x plus y is equals to minus 1. So here x is our dilation factor and y is the translation. So we'll do the same for the other one. So root 10 on 2x plus y is equals to 2. So now we have our two equations, we have our two variables, so then we can solve this and we'll obtain our dilation factor and translation quite easily just by doing that. So solve, and this one over here, so then we got negative square root of 10 divided by 2 times x plus y has to be minus 1. And if I were to copy this, copy and paste, that times x plus y equals to 2 comma x comma y. Okay, so there we go. So this is our dilation factor and this is the translation that we need to match the x coordinates. Pretty simple with this method now. Okay, so let's list it down. So first, dilate by a factor of 3 root 10 on 10. From which axis do we dilate it from? Since x coordinate is changing, we dilate it from y value, from y-axis. Then we have translate what was it? Yeah, half units. I lost my word. Half units in the positive direction of x-axis. Okay, and the last one is just moving the graph up by 9 on 4 units. So translate 9 on 4 units in the positive direction of y-axis. Okay, so these are the dilations and translations you need to go from local minimum of h to local minimum of g. So these two are for the x coordinate and this one is here for the y one. Okay, hopefully this method makes sense, makes everything quite a bit more easy. So let's move on to the next question. Oh, question 2. A model for the temperature in a room in degrees Celsius is given by this, okay, where T represents time in hours after the heater is switched on. Okay, express the derivative as a hybrid function. Alright, so we'll define f. So define f of t is equals to, go here and we use this one. No, sorry, this one. There we go. So 12 plus 30 times t, and 0 less than or equals to t less than or equals to 1 on 3. Now again we do 22 where t is greater than 1 on 3. Okay, just making sure I've defined everything correctly. Yes, I have. Okay, now we just have to differentiate this. Menu for 1 x f of x. Okay, so this is our hybrid function. So let's copy that down. So f dash of t is equals to, so 30 comma 0 less than t less than 1/3, and 0 and t, sorry, not x, t is greater than 1 on 3. Okay, find the average rate of change in the temperature predicted by the model between t equals to 0 and t equals to a half. So average rate of change is just finding gradient. Okay, so f of 1 on 2 take away f of 0 divided by 1 on 2 take away 0, and we will find that. So let's do this on CAS. So f of 0.5 take away f of 0 divided by 0.5 minus 0. So 20. So 20 degrees Celsius per hour. Now please make sure you guys write the unit. Very important for these questions. Okay. Another model for the temperature in the room is given by this over here. Okay. Find the derivative of g. Cool. So let's define g of t. G of t is equals to 22 minus 10 times e to the power of minus 6 times t. Did I define it correctly? Yes, I have. Okay, cool. So derivative of that, so menu for 1 dt of gt And maybe if I were to just quickly define that as well, of t is equals to that. So dg of t is equals, okay, so 60. So g dash of t is equals to 60e to the power of minus 6t. Okay, so find the value of t for which the derivative is equals to 10. Pretty easy. So solve dg of t is equals to 10, sorry, not 0, comma t. There you go. So t is equals to 0.299 9 hours. Okay, so please make sure you guys write the units. I mean, it doesn't specify to write the units. However, it's better if you guys just do that, because sometimes they do have a mark allocated for a unit. So best if you guys write it, better to be safe than sorry. Okay, so let's move on to the next question. So find the time which is between 0 and 1 when the temperatures predicted by the models f and g are equal. Give your answers correct to 2 decimal places. Okay, so they're basically asking us to find f of t is equals to g of t. Okay, so let's do this on CAS. So solve f of t equals to g of t, comma t. Right. Okay, so that's pretty weird. Well, we may have to specify the domain because the t is meant to be between 0 and 1. So let's try and do that and see what the answer is. Okay, so t is equals to this. Okay, so 1 times 10 to the power of minus 38. That is basically saying it's 0, essentially. So our answer would be this one over here. Okay, so it will be t is equals to 0.266. 2 decimal places, 27 hours. Okay? Okay, so find the time when the difference between the temperatures is predicted by 2 models is the greatest. Give your answer to 2 decimal places, and again the time is between 0 and 1, so good to keep that in mind. So we are basically finding this, so d dt f of t minus g of t, then we set it equals to 0 to find the maximum basically. So let's do this on CAS now. Okay, so rather than using the derivative method, what I'm going to do, I'm going to try using f max and see how we go. So we got f of t minus g of t, comma t, comma what's our domain? So it is from 0 to 1. Okay, enter. There you go. So this is your answer. If I were to maybe plot it, let's see how it looks. Curious. So we got f of maybe x. I'll just do x. Maybe for a. Okay, and f of g of x. Okay. So 0.33. Yeah, somewhere around here. As you can see, it is maximum indeed. Okay, cool. So our t is equals to 0.33 hours. Again, please make sure you guys write your units. And yeah, so all of these are just 1 markers. So that means just the answer is required. Okay. Alright, so let's move on to the next question. So the amount of power in kilowatts used by heater T hours after it is switched on can be modeled by continuous function P, whose graph is shown below. Okay. The amount of energy used by heater in kilowatts can be estimated by evaluating the area between the graph, okay, and the t-axis. Okay, cool. So the area under the graph will give us the amount of energy used. Okay. Now, given that P is continuous, show that A is equals to 1.2 times e to the power 4. Okay. So if P was meant to be continuous, that means at t equals to 0.4, this part over here would equals to 1.5. So let's use that information to find the value of A. Okay, so we have 0.3 plus A times E, what was it, to the power of minus 10 times 0.4 is equals to 1.5. Now, whenever a question is asking you to show that, please make sure you list out all the steps and not just say in the next line that A is equals to, whatever the answer is given. No. please make sure you list out all of the steps that you took to get to the answer. That's the point of the show that questions, okay? So let's solve this. So a times e to the power of minus 4 is equals to 1.2. So a is equals to 1.2 over e to the power of minus 4. And therefore, our a is equals to 1.2 times e to the power of 4 as required. Okay? So find how long it takes after the heater is switched on until the heater has used 0.5 kilowatt of energy. Give your answer in hours. Okay. So we know that if we calculate the area under this graph, we'll get the amount of energy used. So now what we have to do is to find a value of t such that the area is 0.5. That's essentially what we need to find. So our integral would go like this. So from 0, wait, it's 0, right? Yeah, 0 there. 0 all the way to t of pt dt is equals to 0.5. And now all we have to do is to find the value of t. So I have to define it first. So define p of t, another hybrid functions. And this one, you get 1.5. And our domain is 0 less than or equals to t less than or equals to 0.4 and 0.3 plus the a value, which is 1.2 times e to the power of 4. So that's the a value times by e to the power of minus 10 times t, and that has to be t is greater than 0.4. Okay, so just making sure I've written it correctly. So 0.3, yep. 1.2, so this is the a value, which is indeed correct. And we times it by this, which is also true. Okay. Oh, forgot the equal to sign. Oh, there we go. Okay, so now we just have to integrate this. So menu 3, 1, so we have to solve for t. So now menu 4, 3. So 0 to t of p of t dt has to equals to 0.5, and we need to find the value of t. So enter, and this is the t value. Okay, so our t is equals to 0. Oh, wait. It doesn't say how many decimal places. So I guess they want an exact answer. I mean, our answer was just 0.33333. So we can tell that our t is just 1/3, okay? Alright. Yep. So find how long it takes after the heater is switched on until the heater has used 1 kilowatt hour of energy. Give your answer in hours, correct to 2 decimal place. Okay. So now instead of finding it for 0.5 kilowatt hours, we have to now find it for 1. There's absolutely no difference in here. So we just have to change the integral. So from 0 to t, p of t is equals to 1, and we are solving for t. Okay, so let's do that. So solve for t when this is equals to 1. So t is equals to 1.33 hours. Okay, so nothing quite different about this. Just make sure it's consistent. Okay, so 0 to t, p is equals to 1. Okay. Okay. The points shown on the chart below represents monthly online sales in Australia. The variable Y represents the sales in millions of dollars. The variable T represents the month when the sales were made. T1 corresponds to January 2021. T2 corresponds to February 2021, and so on. Okay. A cubic polynomial, this can be used to model the monthly online sales in 2021. Okay. The graph of PT is shown as dash curve on the set of the axis above. Okay. It has a local minimum at this and local maximum at this. Okay. Find correct to 2 decimal places the value of A, B, C, and D. Okay. Well, we already have our 4 things given. So we know that P of 2 is going to be 2500. P of 11 is going to be 4400. P dash of 2 is equals to 0 because there is a local minimum, so stationary point, and that's why the gradient is going to be 0. And same thing for derivative at 11 is equals to 0, because again it has a local maximum, meaning 0 gradient. So using these four conditions, we can easily find the value of a, b, c, and d. So let's do this question on CAS. So define p of t is equals to a times t to the power of 3 plus b times t to the power of 2 plus c times t plus d. Just making sure I've written it correctly. Yes, I have. Okay, so let's differentiate it as well. So define dp of t is equals to menu for 1 tp of t, enter. Okay, so just making sure. Yep, okay, now we can just solve this. So solve, and we can do this one, and we do 4 because we have 4 things to solve for. So now we just substitute the coordinates. So p of 2 is equals to 2500, p of 11 is equals to 4400, dp of 2 is equals to 0, and dp of 11 is equals to 0, comma a, comma b, comma c, comma d. Enter. There you go. Okay, so our a is equals to minus 5.21, our b is equals to 101.65, our c is equals to minus 344.03, and our d, I can't see it, so yeah, 2823.18. Okay, so that's that. Now let q equals to this, and it to be a cubic function obtained by translating p, which can be used to model monthly sales online in 2022. Okay, find the values of h and k such that the graph of qt has a local maximum at 23 and 4750. Okay, so the local maximum for p of t was, what was it, 11 and 4400, right? Because that's where the local maximum occurred. And now that p graph is translated up into the whatever, there has been some translations applied, and now we have to find out if I want to make the total, the local maximum to 23 and 4750, what is the value of h and k. So we are basically asked to find the translations again. Quite a lot of they are assessing quite a lot on transformations in this exam, but anyway, so remember that this over here is going to the right, so translating h units in positive direction of x-axis, and plus k is translating k units up in the positive direction of y-axis. Okay, so all we have to do is to find, I want to go from 11 to 23. How many units do I move to the right? 12. So a h value is going to be 12. And if I want to go from 4400 to 4750, how many units do I move up? 350. So a k is going to be 350. Hopefully this makes sense. Okay. Alright. So another function can be used to model monthly online sales, where f of t is this. Okay. Alright, so complete the graph of f on the set of axes above until December 2023. That is, for t is equals to 24 to 36. Label the endpoint with its coordinate. Okay, so for that, let me define the function f. So define f of t is equals to 3000 plus 30 times t plus 700 cosine of, with the cosine of pi times t on 6, okay, plus 400 times cosine of pi times t on 3. Okay, just define it correctly or not. Let me just quickly check that. So 400 cosine of this, yep, 700 cosine of pi t on 6. Okay, cool, define all correctly. Now we have to finish the graph. So what we'll do is we'll plot the graph here. So control I2, and you'll do f of x, and with the specified domain of 2 24 less than or equals to x less than or equals to 36. Menu for A. Is it going to adjust menu for A? No? Okay. Maybe I'll try that again. Of X. Menu for A. Okay, there we go. It did adjust. Yeah, there we go. So this is our graph over here. So now I'm going to remove this. So if I can remove that. Yeah, there you go. So this is our graph. Weird that if I put in a domain, it doesn't adjust, but okay, whatever. So we have to finish this graph here. So let's find all the turning points basically, and then we just have to graph it. So menu 6 maximum, so 6 3. There you go. Of course, we just need the x coordinates, and then we can find the y coordinates quite easily after that. So menu 6 minimum now, so just here, so there. Menu 6 3 maximum again. Menu 6 2 minimum, and finally the maximum again. So menu 6 3. There you go. So we have our set of coordinates, the turning points basically. We just have to copy them down and plot them on the graph. So let's do that. So let's find the actual coordinates first. So f of 24, which is already given on the graph, so we just have to continue from there. So f of 27.8. The only reason why I'm substituting the values in is to get rid of this e plus 3. That's basically saying 3.28 times 10 to the power of 3. But I want the decimal, which will be better. So let's label that. Actually, let me just get all of the coordinates first. So f of 30.1, f of 30.1, okay. And then f of 32, okay. And f of 36.5. Oh wait, no, 36. What am I doing? 36. Okay. So the reason why I've only based it off the coordinates shown in the graph is because we just have to simply plot it. We are not asked to give the coordinates of it, so I'm not gonna worry about the exact, the exact values. So that's fine. We just have to graph it. So yeah, this is also fine. Saves a lot of time. Okay. So let's quickly just graph this using the points that we just found. So 27.8 and 3281. So 27.8 and 3281 somewhere here. And 30.1 and 3600. So 30.1 and 3600 somewhere here. And then we have 32, which is 3410. So somewhere around here. And then we got 36, which is 5180. So somewhere around here. Okay. So we got like that. That. Okay. Oh, maybe. Okay. Yeah, that is better. Okay. So we have to label this point as well. So 36 and what was it? 5180. Okay. So the function f predicts that every 12 months, monthly online sales increase by $n million. Find the value of n. Okay, so in that case, what the question is basically asking us, let me just draw a couple of lines here. So here, and then the maximum here as well. So here, and I'll just move this a bit up, like so. Okay, so the distance between this and this, and this and this is fixed according to the question. So all we have to do is to find that distance basically. So what we have to simply do is f of 12 take away f of 0, right? And that will give us the fixed amount. So let's do that. F of 12 take away f of 0. So 360. Let's try this for the next 12 months as well. So f of 24 take away f of 12 just to be very sure. 360. So our n value here is confirmed to be 360. Okay? So 360. Find the derivative of f. So again, we just have to differentiate. So doing this on CAS, so menu for 1. Let me define it as well. df of t is equals to dt f of t. So df of t is going to be that. So let me just copy that down. So f dash of t is equals to minus 400 pi on 3 times sine pi t on 3. Take away 350 pi on 3 sine pi t on 6, and then plus 30. Okay, hence find the maximum instantaneous rate of change for the function f correct to the nearest $1 million per month, and the values of t in the interval from 0 to 36 when this maximum rate occurs correct to 1 decimal place. Okay, so when we have to find a maximum of something, what do? We differentiate, right? We have to find the maximum instantaneous rate of change. So we have to find the maximum of the instantaneous rate of change. So what does this give us basically? What is this function here? This function, the one that we just calculated, the derivative of f, is the rate of change. And if I want to find the maximum of that rate of change, what do I have to do? I have to differentiate it again, right? So our solution will be f double derivative of t has to equals to 0. Okay, so let's do that. So menu, actually let me define as well. So define ff of t is equals to menu for 1 t and df of t. Okay, so our ff of t would be this whole thing. Alright, cool. So let's solve this now. So ff of t is equals to 0 and comma t. Let's put in the domain as well so that we don't get the general solution. So 0 less than or equals to t less than or equals to 36. Okay, that's a lot of values actually. This will take up a lot of time to. Is there a quicker way of doing this, I wonder? Actually, yeah, there is one way I can think of right now. So we are basically finding the maximum of the instantaneous rate of change, right? So we are basically finding the maximum of df of t, right? So what we can do is that we can graph this function and see where the maximum occurs, basically. So then that will make it a lot more easier to take the points, right? So if the maximum occurred at 10.2, we only have to substitute in 10.2 and call it a day. So we can just simply graph this and get our information that way as well, which works. So Control I2, df of x, and we'll go from 0 less than or equals to x less than or equals to 36. Okay, menu for a. Okay, now it actually did adjust, unlike last time. Pretty weird. Okay, so we are finding the maximum of the rate of the change function. So we have to find the maximum of this, which is here. So how many peaks are there? Okay, so there are 3 peaks, so we'll only have 3 values of t. So menu 6 maximum. So our t one maximum will occur at 10.2. Let's find the other ones as well. So 6, okay, 22.2 and menu 6.3, which is 34.2. Okay, well, that made everything a lot more easier, saves a lot of time as well, and it asks us to write it to 1 decimal place. Okay, even better, we do not even have to substitute these values in to find the exact coordinates, exact maximum rate of change. We can just use 10.2 and 725, call it a day. Yeah, that just made this question a whole lot easier. So t is equals to 10.2, t is equals to 22.2, and t is equals to, what was the last value? 34.2. 34.2. And our maximum rate is basically 725. Okay? Yeah, so that made the entire question quite easy. So graphs always help. So if you are stuck, just graph it out and you mostly get your answers that way as well. Okay, so let's go to the next page. Okay, question 4. At an airport, luggage is weighed before it is checked in. Okay, The mass of each type of luggage in kilograms is modeled by a continuous random variable x, whose probability density function is this. Okay. A piece of luggage is labeled as heavy if its mass exceeds 23 kilograms. Write a definite integral which gives the probability that a piece of luggage is labeled as heavy. Okay, so that is just from 23 to 30 f of x dx. That's our definite integral. Okay, so find the mean of x. Very well. So in that case, let's define the function first. So define f of x is equals to, we have a piecewise function again, so we need this one, 1 on 67500 times x squared times by 30 minus x. Okay, 0 less than or equals to x less than or equals to 30, and this one is 0. So enter. Yep, I've defined it correctly. Now we have to find the mean value of x. So that would just be 4, 3, and we have to go from 0 to 30. X times f of x dx. Enter. There you go. That's our mean. So our mean was basically 23 to 30 x times f of x dx, which was equals to 18 kilograms. Now, please make sure you write the units again. So if it's kilograms, write kilograms. Write the appropriate units everywhere, regardless of whether they ask or not. It's always better to be safe than sorry, okay? Find the standard deviation of x. Okay, so for that, we have to first find the variance, and then we have to square root that. So our variance is going to be given by 23 to 30 x squared times f of x dx, take away the mean, which is 18 squared. So let's find this on CAS. So menu for 3, what is it, 23, oh wait, it has to be from 0. What am I doing? 0, not 23, 0 to 30 x squared times f of x dx, like that. So 360, and then we have to take it away, so squared. So 360 minus 324, we have 36. Okay, so variance is 36 kilograms squared, and so our standard deviation we know is going to be the square root of variance, which is equals to square root of 36, which is equals to 6 kilograms, I mean. Okay, given that the mass of a piece of luggage is more than the mean, find the probability that it is labeled as heavy. So we're basically finding probability that x is greater than 23. Is it greater? Exceeds, yeah. So given that the mass of the piece luggage is more than the mean, find the probability that it is labeled as heavy. So given that x is greater than the mean, which was 18, right? Yeah, okay, cool. So if I were to draw a number line real quick, so we'll have 18, we are going from here, and then 23, we are going from here. Okay, I just realized I drew number line in the wrong place. Maybe this would be better. Okay, so the intersection is basically going to be here somewhere, right? So we are basically finding probability that x is greater than 23 divided by probability that x is greater than 18. Okay, that's what we are finding essentially. Alright, so in that case we just have to put this on CAS. So menu for 3, and from 23 to 30 f of x dx. Okay, and then we will find the same thing but for 18. Okay, now we just divide these two. So 0.446, 3 decimal places. Okay, all right. Of the travelers flying from the airport, 10% do not check in any luggage, 40% check in exactly one piece of luggage, and 50% check in exactly 2 pieces of luggage. Okay, assume that the mass of each piece of luggage is independent of the number of pieces checked in by the traveler. Use the value of 0.234 for probability that piece of luggage is labeled as heavy. Let W be the discrete random variable that represents the number of pieces of luggage labeled as heavy checked in by each traveler. Show that probability that W equals to 2 is equals to 0.027. Okay, so 50% checks exactly 2 pieces of luggage. And we will show that okay, so it will be, because only 50% of the people actually carry 2 pieces of luggage, so we will do 0.5 times the probability of success, so 0.234 squared. Why is it squared? The reason being that they are carrying 2 bags and we want both of them to be heavy, so that's why we have to square it. So if I were to do this on CAD, so 0.5 times 0.234 squared, yeah, there you go. So we get the required answer, 0.027. Okay, complete the table below for the probability distribution W equals W, correct to 2 decimal places. Okay, so when W equals to 1. Okay, so if I'm carrying, so let's look at the scenario first for W equals to 1. That means 1 luggage is heavy. Okay, so probability that W is equals to 1. So basically, let's say if I'm that 40% of the people who are carrying exactly 1 luggage, I want it to be heavy regardless, right? So we'll have 0.4 times 0.234 plus, now let's say if I'm carrying 2 luggage and I want one to be heavy, so it could be the first one that's heavy or the second one that's heavy. So what we'll do, we have to do 2 times 0.5 times, I want one to be heavy and one to be not heavy. So for one to be heavy, I times it by 234, sorry. And then I times it by one to be not heavy, which is 1 minus 0.234. Okay? That's the basic gist. So again, I'll go through it real quickly. So let's say I'm only carrying 1 luggage. That means I need that luggage to be heavy if I want W equals to 1. So that is ensured by this term over here. Now let's say I'm carrying 2 luggages. I want either first one to be heavy or the second one to be heavy. So that's why we are multiplying it by 2. And times 0.5 is because, well, only 50% of the people are carrying 2 luggages. I want one to be heavy, so that is where this term came from, and one to be not heavy, where this term came from. Okay? Hopefully that clears everything up. So let's quickly, after I remove this, put this on CAS. So I got 0.4 times 0.234. Okay? And then 0.5 times 0.234 times 1 minus 0.234. And that gives us that. Oh, times it by 2. Forgot that. Okay. So if I were to add these two up, I get 0.273. Okay. And now probability that W is equals to 0. So I'm traveling with no matter what, how much bag I have on me, I need 0 bags to be labeled as heavy. So let's say I'm only carrying 1 bag, so the 40% of the travelers. So 0.4 times I want it to be not heavy. So 1 minus 0.234 plus, I'm traveling with 2 bags now, so 0.5 times, I want both of them to be not heavy, so 1 minus 0.234 and squared. Now remember, the 10% do not check in any luggage. So if they don't bring in any luggage, of course they're not going to be, they're not going to have any bags labeled as heavy. So we add that up to, so 0.1. So let's see what we get. So 0.4 times 1 minus 0.234 plus 0.5 times 1 minus 0.234 squared. Forgot the multiplication sign. And then plus 0.1. Plus 0.1. So I get 0.7. 0.700. Because it's asking for, 3 decimal places. Okay? Hopefully all of this makes sense. Alright? So let's move on to the next question. On a particular day, a random sample of 35 pieces of luggage was selected at the airport. Let P hat be the random variable that represents the proportion of the luggage labeled as heavy in a random sample of 35. Okay? Find a probability that P hat is greater than 0.2 to 2 decimal places. Okay, so we know that P hat is equals to X on N. So we're basically finding probability that X on N is greater than 0.2. Our N was given to be 35. Okay, so in that case, we have probability that X is greater than 35 times 0.2. So 35 times 0.2, I get 7. Now, so that is going to be the same as probability that X is greater than or equals to 8, right? Okay? Because, well, we are now looking at like discrete stuff, or maybe, we are looking at like the binomial discrete stuff. So where if it's greater than 7, it's going to consider greater than or equal to 8. Okay? So that's why, and of course, we cannot have, point something of a luggage. There's going to be discrete quantity of luggage bags. So that's why we always have to look at, if it's greater than 7, it's going to be greater than or equal to 8. We always have to take 8 into consideration. Okay? So let's solve this on CAS. So menu 55B. So we have number of trials, which is 35. Probability of success is 0.234. Lower bound is going to be 8. Upper bound is going to be 35. Okay, enter. So I get 0.595. Okay? Determine the probability that P lies within 1 standard deviation of its mean, correct to 3 decimal places. Do not use normal approximation. Okay, so we are basically finding probability that mu minus sigma, where mu is the mean and sigma is the standard deviation, and that less than plus sigma, because we are finding for 1 standard deviation, right? So if it was for 2 standard deviation, we have to put 2 and 2 here, okay, and so on and so forth. All right, so let's write down the formula. So probability that how do we calculate mean in binomial? So it's just n times p. Take away standard deviation is n times p minus 1 minus n times p times 1 minus p, less than x less than np plus n times 1 minus p. Okay, so what is our mean over here? So mean is 35 times 0.234, which is 8.19. So probability that 8.19, take away about the standard deviation, so square root of 35, 35 times 0.234 times 1 minus 0.234. So 2.5047 less than x less than 8.19 plus 2.5047. Okay, so probability of 8.19 minus that and that plus that. Okay, so we are finding probability that x is between 5.68, maybe 5.69, less than x less than 10.69. And now we just have to use the binomial distribution to find our probability. So that and that and that. 0. So a probability which is 0.68, was it 3 decimal places, 684. Okay, now this actually makes sense. The reason being that when you are one standard deviation away, the probability is like 0.68, right? So that is making sense how close it is to 0.68, so that's good. And also, you notice how I inputted a bunch of decimals in here as well with the binomial, even though it is, dealing with discrete stuff. It doesn't really matter. If you put a decimal, binomial, this CDF will adjust by itself. So you don't have to worry about that, okay? Alright. In one random sample of 50 pieces of luggage, 10 are labeled as heavy. So we have to find the 90% confidence interval for P to 3 decimal places. Okay, using CAS again, so menu 665. So number of successes is 10, number of trials is this, number 0.90. That's okay. Of course I get a bunch of fraction. There we go. So lower and upper. There you go. So just copy that down. So 0.160 and 0.411. A second random sample of 50 pieces of luggage is selected. Using this sample, the approximate 90% confidence interval for P, the population proportion luggage labeled as heavy is wider than the one obtained above in part before this. Okay. State the minimum and maximum possible number of pieces of luggage labeled as heavy in the second sample. Right. So I guess they're basically just talking about the marginal error. So I feel like if you do z times p hat 1 minus p hat over n, and they want it wider, so this has to be greater than z times square root of p hat 1 minus p hat divided by n. I'm pretty sure this is what they're after. Now I guess we remove these because we already know that our n is just 50, so that's all good. So our second random sample of 50 pieces is selected. Using this sample, approximate this. Oh, hold on. So we have 10 labeled as heavy. So we can find out. So this one has to be 1 on 5 because 10 on 50 times by 4 on 5. So we are basically looking for the new p hat value, which gives us a wider, I guess, confidence interval. So that's why I have this inequality set over here. So we're just basically solving for the value of p hat here. So let's do this on CAS. So solve and square root p hat x times 1 minus x divided by 50 has to be greater than, copy the same thing down, (1 on 5) times 4 on 5. If I do solve for x, okay, so we get these values over here. So that means we have to find the values of x, which would give us the, so basically what we have to do is to find probability. We are given that p hat has to be greater than 1.5. So we are basically finding, so it has to be between 1/5 and 4/5. So 1/5 times p hat, or maybe x on n, and that is 4/5. And our n is given to be 50. Yeah. So we have 10 less than x less than 40. Okay. So it has to be between 10 and 40 basically. So that means it has to be 11 and 39, because again we are dealing with discrete stuff, right? So if it can't be 10, it has to be more than 10. It has to be 11. And if it can't be 40, but it has to be less than 40, it has to be 39. So that means the minimum is equals to 11 and maximum is equals to 39. Okay, hopefully this makes sense. Very interesting question. It's a good question, by the way. Okay, yeah, I think that should be good. Yeah, okay. Question 5. So a graph below shows the compositions g of f and f of g, where f of x equals to sine and g of x equals to sine 2x. Okay. The graph of g of f of x has a local maximum, whose value lies in the interval of this. Find the coordinates of this local maximum. Okay, so in that case, let's define g of x and f of x real quick. So define f of x equals to sine of x. Define g of x is equals to sine of 2 times x. G of f of x is this, okay? And we need to find the local maximum. What if I do f max? Does that work here? So g of f of x, g of f of x, comma x, comma 0, comma pi on 2. Okay, what? It gives me a general solution, which shouldn't happen. That is very strange. It's saying correct to 1 decimal place. So do I just like graph it? That's the only way out, right? So control I2, g of f of x. Okay. And I'll restrict the domain. 0 less than or equals to x less than or equals to pi on 2. Okay. Menu 6, 3. Okay. So I guess our coordinates will be 0.9 and 1.0 basically, if it's asking for just 1 decimal place. That's interesting how CAS didn't give us that. Very strange. Okay. Say the range of g of f where x is between 0 and 2 pi. Okay, so let's change the domain to 2 pi. 2 pi. Okay. Yeah, so the range is just -1 to 1. I'm just going to quickly confirm this. 6, 3. Menu 6, 2, I mean. Yeah, so the range is just from -1 to 1. Okay. So -1 to 1. Okay. Find the derivative of f of g. Okay, so f of g of x. We need to find the derivative, so menu for 1 x. Okay, so our derivative, so f of g dash x is equals to 2 cosine 2x cosine and sine of 2x. Show that the equation this has no solution. Okay, so basically 2 cosine of, okay, actually I don't need that, so cosine of sine 2x is equals to 0. So that means we have sine of 2x is equals to cosine inverse of 0. So sine of 2x is equals to pi on 2. Yeah, okay, that makes sense, because if I were to graph a sine function, so you can see that the range is just between 1 and -1 here, right? And because pi on 2 is, yeah, bigger than 1. So if pi on 2 is bigger than 1, of course it's going to have no solutions. So if the range, yeah, because the range is not good enough. So we can say that the range of sine of x equals to -1 to 1. And since pi on 2 is greater than 1, equation has no solution. Equation has no solutions. Okay, find the x values of the stationary points where x is between 0 and 2 pi. Okay, so we have to set the derivative equals to 0. So solve that is equals to 0 comma x, and the domain is 0 less than x less than or equals to 2 pi. Again, it's giving me general solutions. This is so weird. Why is CAS not able to solve this? Okay, that doesn't really matter, because we know that this term won't have any solutions anyway. So we only have to set this equals to 0, right? Let's try that, because if that doesn't work as well, then that's just quite interesting behavior of CAS. So if I do that, didn't set it equals to 0. There you go. Oh, there you go. Fantastic. Okay, so this worked. Well, the reasoning behind that, why did I ignore the second term? So, because in the previous part, we just proved that this term, set equals to 0, will not have any solutions regardless of what we do. So, basically, this term is just irrelevant when we are finding the stationary points. So that's why I just canceled this term out, and I just left this term over here, and set it equals to 0. Okay? So setting that equals to 0 and setting the domain, we get these solutions over here. That's the reasoning. So let's copy that down. So x is pi on 4, 3 pi on 4, 5 pi on 4, and 7 pi on 4. Find the range of f of g of x where x is between 0 and 2 pi. Okay? So let me plot this. I don't want any trickery. Better if I just plot this. So f of g of x, and we have to be between 0 and 2 pi. So 0 next less than or equals to 2 pi. Okay. Okay, so the sign is, okay, so yeah, it's just going to happen at the given values that we just found, essentially. So if I were to put this one back down here and do that, 0. Oh wait, this is a derivative function. What am I doing? We will actually put it in the f of g of x, so pi on 4. Actually, it would be better if we just do that. Pi on 4. So 0.841 or sine of 1. If I were to do 3 pi on 4, Okay, so I think this is our range. So range is negative sine 1 to sine 1. Okay, so next question. Write a single definite integral that gives the area bounded by the graph of f of g of x and g of f of x on the interval this. Okay, cool. So okay, maybe I'll delete that, and g of f of x comma 0 less than or equals to x less than or equals to 2 pi. Okay, cool. So immediately as soon as I plot it, I can see that the graphs are symmetrical. So area between these two graphs is equal to the area here as well. So the integral would pretty much be, okay, we have to find where they intersect though. We have to find this value. What if I just look at the graph? Okay, it seems like they're intersecting at pi. Yeah, okay, intersecting at pi. That's cool. So our integral would just be 2 times 0 to pi, and then on top the f of x, g of f of x was on top in the first quadrant. Wait, sorry, the g of f of x is on top, so we have to write that first. So g of f of x, take away f of g of x, and that's our integral. Okay, so we have to find the area, so hence find the area bounded by the graphs of this. Okay, cool. So menu for 3 is 0 to pi. We get g of f of x, take away f of g of x dx. Okay, so it's 2, wait, I forgot to times it by 2. So times that by 2. So 4.969. So 2 decimal places would be 4.97. Okay, so find all the, so let f1 between 0 and 2 pi. Find all the values of x in the interval from 0 to 2 pi for which the composition of f1 of g is defined. Okay, so f1 of x, so it's same as f of x. But with a domain this time. So there is basically no difference. But if I want f1 of g, f1 of g of x to be defined, so I'll need the range of g has to be a subset of domain of f, basically. So I'll write that down. So for f1 of g to be defined, range of g has to be a subset of domain of f. So that means, what is our range of g? So our range of g is just -1 to 1. So -1 to 1. And what is our domain of f? So 0 to 2 pi. So then, if we want f of g, f1 of g of x to exist, we would need the range of g to be, the new range of g, I would say, is going to equal to basically 0. So we basically need to find when g of x is greater than 0 essentially. Because currently -1 and 1 is not in the subset. So if I were to draw a quick number line again, so that, and we'll do -1 to 1 like so, and we got f of x, which is 0 all the way to 6 pi. Oh, not 6 pi, 2 pi, which is like 6.28. Oh, that one. Okay, so this is 0 to 2 pi, and the other one is just -1 to 1. So -1 to 1. And we want the fact that this entire thing, this entire range, has to fall under this part over here. So that's how we can tell if there are subsets or not. Currently, as you can see, that this part is not a subset. There is some part which is falling under the domain of F, but we want the whole thing to fall under the domain of F. So for that, what we need to do is to restrict the range for it to become 0 and 1. And now what happens is, 0 excluding. And now what happens is, if I were to move this here, and I'll erase this point, erase that point, and that. Now you can see that it is indeed a subset now, right? So all we have to find for this question is basically solve for x when g is greater than 0, and that will give us our answer. Okay, hopefully that made sense. Okay, so if I were to solve this on CAS, so do I have g of x defined? Yes, I do. So solve g of x is equals to greater than 0, comma x 0 less than x less than 2 pi is our domain. Okay, well, what if I do equals to? Okay, there we go. So if I were to plot g of x, g of x, set the domain, so it's 0 less than equals to x less than equals to pi. Okay, so for g of x to be greater than 0, it's going to be 0 to the first one, so pi on 2, and then this one all the way to here, so 0 to pi on 2, and then and then pi to 3 pi on 2 basically is our answer. So hence our x values is basically going to be from 0 to pi on 2, and then including pi to 3 pi on 2. Okay, that should be our answer for this question. Hopefully this made sense, right? And the reason why it's excluding is because, well, we just had to find it greater than 0, not greater than or equal to, because if I were to include the 0 again, it will become out of subset because 0 is not included for F. So that again will be wrong. So that's why our brackets are exclusive. Okay, hopefully that makes sense. So that's it. Okay, wait, that's it, right? Yeah, okay, cool. Alright, so that's that for methods section B 2024. Hopefully you guys learned something new from this, and thank you for watching. I'll see you in the next video. Bye bye.